Tonight I'm going to present to you Euclid Book 6 proposition number 1. And boy, this is a long proof. You have no idea how long this is. Here's the basic drawing here. You have a point called A. And you're going to draw a whole ton of lines here. And I'm sure these are not exact, but they're as close as I can possibly get them. Anyway, we're going to draw a 3-inch line down here. And it's going to be called BD. And at 1 inch, this is 1 inch right here. This is B to C. This is 1 inch. Alright? And C to D here. C and D here. This length right here is 2. This length right here is 1. Then we're going to extend this line out. And the length of BC, of course, is 1 inch. So is the length of BG. And so is the length of GH. Now here's the challenge. After you draw these like this, and then keep in mind that C to D, see this C to D? That is 2 inches. We also have D to K, which is 2 inches. And then we have D to L, which is also 2 inches. Now, we have to draw lines like this from these points, every one of them, to point A. That becomes the real challenge. Alright, once you've done all that, and you've drawn every single line here all the way up from H to A, G to A, B to A, C to A, D to A, K to A, and L to A, and believe me, that is not as easy as it sounds, then you have to plot 2 more points. Now I have made a length from A to E, which is 1 inch, and another length from A to F, which is 2 inches. And then you're going to draw a line from B to E, and a line from D to F. And you're going to connect E and F together through point A. Once you've done all that, then we can actually get to the actual proof. Triangles and parallelograms which are under the same height are to one another as to their bases. Let ABC and ACD be triangles. Well, let's find ABC. A, B, C. Okay, this is A, B, C. And here's A, C, D. Okay. A, B, C, A, C, D. They are triangles. And let's let EC and CF be parallelograms under the same height. Okay. EC would be actually EBCA. EBCA. That's one parallelogram. And ACDF is the other parallelogram. You like this so far? Well, let's keep going here. Euclid says that as base BC is to base CD, well, where's base BC? As base BC is to base CD, so we're actually establishing a ratio at this point. So as 1 to 2, because remember, BC is 1 inch, CD is 2 inches, so as 1 to 2, so ABC is to the triangle ACD. Well, ABC is to the triangle ACD. Okay? So basically he's saying that the area inside of this is in the same ratio to this as this is to this. So as 1 is to 2, then whatever the area is in here is in ratio to this. So this is basically, the area inside this triangle is twice the size of the area in this triangle. And the area in parallelogram EC, well, area in EBCA, this area right here, so this area right here, it's going to be half as much as the area of ACDF. So ACDF is going to have twice as much area as EBCA. This parallelogram is going to have twice as much area as this parallelogram. That's what we're trying to prove. Okay, for let BD be produced in both directions. Well, BD, this is BD, we're going to produce it in both directions. To the points H and L. Well, obviously BD has been produced to point H, and BD has also been produced to point L. See? BD all the way down. And let any number of straight lines, BG and GH, well, here is BG and GH, BG and GH, be made equal to base BC. Well, obviously, if BG is 1 inch, and GH is 1 inch, and BC is 1 inch, then they're all three equal in size. And any number of straight lines, DK and KL, well, here's DK, and here's KL. This is 2 inches long, this is 2 inches long, and CD is also 2 inches long. Be equal to base CD, which we already established. Let AG, AH, AK, and AL be joined. Okay. Let AG, here's AG, here's AH, here's AK right here, AK, and way over here is AL. We've joined all of them. Then since CB, BG, and GH are equal to one another, well, CB, BG, and GH, all three lengths are equal to one another. The triangles ABC, AGB, and AHG are also equal to one another. Now again, we're talking about areas, and that's by Euclid Book 1, proposition number 38. Isn't this nice? And I can tell you right now that this is going to take more than one video, so just hang in there, folks. ABC, ABC, AGB, AGB, AHG, AHG. So these three triangles will have the same amount of area. Therefore, whatever multiple the base HC is of the base BC, so we have HC, whatever multiple of this is to BC, that multiple also is the triangle AHC of the triangle AABC. Well, here's AH, okay, it starts with A, goes to H, goes to C, and then we have ABC. So, as there are three of these in HC, so there are three triangles with the same area ABC in AHC. Alright, for the same reason, whatever multiple the base LC is of the base CD, well, where's LC? Well, here is L, way over here, and here's C. Okay? LC. Well, here's L, here's C. Whatever multiple of the base LC is of the base CD, CD right here, and there are three of them, 1, 2, 3, okay, so there are actually three CDs in LC. That multiple also is of the triangle ALC of the triangle ACD. Well, here's ACD right here, and there are three ACDs in ALC. There are 3 of these in ACL or ALC. And if the base HC is equal to the base CL, so if HC is equal to CL, which in this case it's not, okay, the triangle AHC is also equal to the triangle ACL by 138. Or, if the base HC is in excess of the base CL, which again it's not, so on and so forth, if the base HC is less than the base CL, then the triangle AHC is also less than the triangle ACL, which in this case is absolutely true. Whew. So far, so good. Alright, I'm going to continue this in my next video, so stay tuned.